Hello. Good morning.
Good morning.
Yeah. Uh, Sorry, I got late today. Uh, Hello. Hello. Am I audible?
Yes, sir.
Yeah. Thank you. So I had to trace the program, 11th program, but I think since there is very less time now, let me go with the program. Okay. BFS non recursive for adjacency matrix. Okay. Uh, So, let us understand this program for today. Yeah. See, I'm defining the size as 20, and then I've taken one more Boolean macro with the name true and initialized to false, and another one false, and I've defined its value as 0. And the size what we have taken is 20. And then I'm creating a graph. Okay. So, sorry, this adjacency matrix with the name G. Okay. Or in other words, you can also call it as a graph, size by size, 20 by 20. Okay. That means you can go for having maximum 20 nodes inside your graph. And then one more array is taken, that is visit of size, because every time you visit a node, we'll be adding it to the visit list. Okay. And then q I've taken, because when you are doing the breadth first traversal, what the data structure that is required is a queue. Okay, we have the queue, and then front and rear, the pointers for the queue, and n to read the number of nodes. The maximum number of nodes you can have up to 20, but within this 20 you can go for choosing your own number of nodes. Okay. So I hope this declaration part is clear to all of you.
Yes, sir.
Okay. Next. Now we have the variables v1 and v2, and then answer is equal to yes, which is a character variable, because I keep repeating doing this. Okay. And then clear screen. Okay, these are the functions. We have one with the name create and clear screen. Okay, that's fine. Now adjacency matrix for the graph is, so you are reading the adjacency matrix here. So we are making use of two for loops. Okay, so v1 and v2 for are the variables which are used inside the for loop. Instead of I and j, we have taken it as v1 and v2, because v1 and v2 corresponds to the vertexes that we are reading. So and then I'm reading the adjacency matrix, and I'm writing it into this G of V1 and V2. I'm filling it into this matrix. Okay. And then, so after reading the matrix, so get a character, and then I'm entering into the do while loop. So where I initially go for marking all the nodes visited as false. Okay. Now visited is an array. So as I already showed you, this is an array of size 20. Correct. Now here I am running this for loop and making visited of v1 is equal to false for all the n nodes. Okay. So for example, I have taken 5 nodes. For every node, I'll make initially visited is false, because when you start initially, you will not be visiting any node. So assuming, so we have not yet visited any nodes, so we are making visited of visited array as false. Okay, and when I visit a node, I go for updating this array and make the corresponding node in this array as true. Okay. So now again I'm calling clear screen. Next I am just calling enter the vertex from which you want to start traversing. So as we did in the previous class yesterday. So it was a recursive algorithm, but what we see now is a non-recursive algorithm. Okay, enter the vertex from which you want to traverse. I'm reading the starting vertex. Okay, and I'm checking if the vertex what you enter, if it is greater than or equal to this, then I say it is an invalid vertex. So for example, if you're told 5 vertexes, and while reading, if you're giving it a 6 or 7, then the program should say it is an invalid vertex. So next, so if this condition is not true, we go to the else part and we just display this message, breadth first search of the graph is, and then we are making a call to BFS, and we are also passing the what, this one, the starting vertex. So for the vertex from where you have to start traversing the tree. So is it clear till here?
Yes, sir.
Okay. Now, and then we'll go to the BFS now. So I hope it is a blur. Can you people see? Is it visible?
Yes, sir.
Okay. Yeah. You can observe now BFS of V1. So this is the starting vertex. I have another vertex in V2. Now what I'm doing, visit of V1 is equal to true. The starting node, I have to mark it as visited right now. So I'm marking it as visited. So initially all the elements in this visit array are initialized to false. We did it here. We initialized everything to false. So now after reading the starting vertex and we make a call to the BFS, so we make it as visited. The starting node is made as visited. Okay. Next, so we are initializing. So since I already told BFS makes use of the queue, so front and rear are initialized to -1. Next, what we do, we got to add the starting vertex to the rear end of the queue. So q plus rear is equal to q1, and then I check while front not equal to rear. Okay, the front is not equal to rear as long as this condition is true. And what I do, I take the element which is there at the front of the queue and add it to V1. Okay, and then I print V1. So this is what the node which I visited right now, or the node which I have traversed, and then use a for loop for V2 is equal. V2 was taken for this purpose, another variable V2. Now V2 is equal to 0, V2 less than n, V2 plus plus. For this number of iterations, what I do, I go for checking this. See, if V1 of V2, okay, so from the starting vertex V1 to V2, if it is equal to true and visit of this is false, that means, so if g of V1 to V2, that means if there exists a path from V1 to V2, if it is equal to true, means what? If there exists a path from the vertex V1 to V2 and the vertex V2 is still not visited, visit of V2 is equal to false, what does it mean? The vertex V2 is still not visited, then what we do, we add V2 to the rear end of the queue and we make visit of V2 is equal to true. And this process we keep repeating for all the vertices in the graph. Hope it is clear?
Yes, sir.
Okay. So this is a non-recursive. So we are not calling it recursively here. You can just observe. So this function is not called recursively. So this is not a recursive call. So what we have implemented is a non-recursive function. And similarly, you can also go for implementing the DFS by using a non-recursive function. Now instead of queue, so you have to use a stack over there. Okay. And then okay. So and this. Okay. So BFS, after BFS, so get CH, and then again we are asking, do you want to traverse from any other node? Now I get the answer. If the answer is yes, then again I go back, I read the one more element and I repeat. Okay. So now this part is again to program to create a graph and display in the breadth first manner, enter the number of nodes, and here we're reading so we are initializing the entire matrix value to false, everything to 0, and enter the vertex number starting from 0. Reading here, invalid vertex. Okay, so add more edges. Oh, this is for adding the edges. This part of the code is for adding the edges, and let us not worry about this. So our focus was on traversing the graph by using BFS without the recursive technique. So this is what we understood. So now the next topic, is the sorting and technique. And before going to the sorting and searching techniques, okay. So now I can go for tracing the program. Yesterday's program. We'll quickly trace the program and we will try to complete it. Okay, I go for F7 now. So read the adjacency matrix. Can you people see my screen?
Yes, sir.
Okay. So reading the number of vertices, 5. So can you people just tell me the matrix which I gave you people yesterday?
Yes, sir.
Okay, 1 second. Yeah.
0 1 1 0 0
0 1 1
0 0
00 F7. Okay, yeah, tell me the second row.
1
Now all the 5 elements are red now. Okay, 1
0 0
0 0
1 0
what?
1 0
1 0. Okay, thank you. Now, so it is reading. So reading the second element, first element from the second row. So I am pressing F7. Okay. Now it read the second element from the second row, third element from the third row, fourth, fifth. So, and now, so it is back. Okay. Yeah.
1 0 0 1
1 0 0 1. So reading. Yeah. Fourth row.
0
0
1 1
1
0 1
0 1. Now the last one. Yeah.
0 0
Double. Oh, sorry. 0 0
1
1 1
0
0. So this is the matrix that we have read now. Now enter the starting vertex. We are reading the starting vertex. Okay. Now, so starting vertex, we will what we took yesterday.
1.
1. So 1 is the starting vertex. Okay. So now we are making a call to DFS. Okay. And while calling DFS, what we have passed is the start. Now the starting vertex, what I have entered 1, it is copied to start, and DFS of start is called, and so DFS of V is start right now. Okay, V is 1 right now. Now what we are doing inside this, so we are marking visited of V, visited of 1, visited of 1, V value is 1 right now, because the starting vertex what we have entered is 1. So you can just observe here, Control Alt F5. So the starting vertex we have taken it as 1. So now we are making visited of 1 is equal to 1. 1 means why I am initializing it with 1? So it means it is visited. Okay, or you can instead of 1 you can also go for taking it as true. Okay, now running a for loop for W is equal to 1. So W less than or equal to N and W plus plus, and N value is 5, you already know. Now 1, so W value is 1, 1 less than or equal to 5 condition is true. Now we get into the for loop, and then we are checking whether visited of W. What is the value of W right now? 1 in the first iteration. Visited of 1 is equal to 0. But the node 1 is already visited. We have already told that visited of 1 is equal to 1. Okay, this condition is false right now. Visited of 1 is equal to 1, but what we are checking, the condition is visited of 1 is equal to 0. So this condition is false. So when this condition is false, so it will not go into this if statement, because the operator what we are using here is AND. Okay, both must be true. Okay, and you need not check for this condition. When this itself is false, so we skip this iteration and we go to the next one. Okay, so you can just observe now. I press F7. Okay, so I pressed F7. It skipped that execution because I could not show you. See, I pressed F7. The control stayed there only. Okay, and it went back to the for loop, and it is in the second iteration right now. Okay, now I think for you to check that, I need to add the trace window, watch window. Let me add the watch window. Now the value of W is not 1, it is 2. I'll just show you. Okay, I'll add W. See, W value is 2 right now. That means, so we're in the second iteration. OP people understood?
Yes, sir.
Okay, and let me add one more. We'll add W I have added. Let me add visited of W also. Visited of W. Okay, see, visited of W is 0. What does it mean? The node 2 is still not visited. Okay, it's still not visited, and what shall I add? Let us add this A also. Okay, the adjacency matrix. See, A I have added. So here in the adjacency matrix, you can see This is 0 0 0. 1 second. But I don't know why it is taking zeros. Okay, let me add one more. It should be of 5 rows, right? In each one we should have 5 elements, but I don't know why it is showing 10. Okay, let me check it. So add watch, I'll add a of v, a of v, and then w. So this also will add. Okay, so a of v also let me add. Okay, so you can see now v is 1, w is 2, a of 1 2 in the matrix, a of 1 2 is 1. Okay, so a of 1 2 is 1. Okay, if you just look into the matrix, let me go back to the matrix. So a of 1 2, so first row second column is what? 1. Okay, so now I'll press F7. So now this gets printed. So what gets printed? 2 gets printed. So Alt F5 if I press, you can see here. So from after 1, what we are visiting is 2. Next, now we are calling DFS of 2. So DFS of 2 we are calling. So because W value is 2, so recursive call it is. Okay, so we are back to the DFS, and V value right now is 2. So the W value is copied to 2 now. V is 2 right now. Okay, so V is 2, W is 2, and again, so visited of V. Okay, yeah. I forgot to put the visited of V also. Let me add visited of V also. Visited of V. So visited of, where is it? Yeah, visited of V is 0 right now, but V value is what now? 2. Visited of 2 is equal to 1 we are doing, because we are visiting the node 2 right now. So visited of 2 is also made as 1. Okay, so and you can go for displaying the visited array also. See, if you look into the visited array, so we have visited the node 1, and next we have visited the node 2. Okay, and here, yeah, so visited node 1, and now we have visited node 2, and again for W is equal to 1, W less than or equal to N, W plus plus, so W gets the value 1. Okay, so W is 1. Now visited of 1 is equal to 0. Now visited of 1 is what? True, because 1 is already visited. Okay, we escape. And now W is 2, you are checking visited of 2. So 2 is also visited already. Okay, so 2 is also visited. Now again we skip. I press F7. See, it got skipped. Now W is 3. Okay, so visited of 3, what we are checking, it is equal to 0. Yes, true. And what we are checking is whether there exists a path from what is the value of V? V is 2. Okay, so whether there exists a path from 2 to 3, because the current node, the node which we have visited right now, more recently is 2. First we visited 1 and then we visited 2. Now I am checking whether there exists a path from 2 to 3. So from 2, V value is 2 and W value is 3. I am checking whether there exists a path from 2 to 3. So if there exists a path from 2 to 3, it will be equal to 1. I don't know whether there exists a path from 2 to 3. Let me go back to the Alt F5. So 2 to 3. So just look into the matrix. So 2 to 3, is there a path? Yes. Is there a path from 2 to 3?
No, sir.
So this is 1 and this is 2. 2 to 1, there is a path. Yesterday you wrote a matrix, right? You just look into that. Yeah, and then 2 to 3, there is no path. Correct, right? See,
Yes.
if a second row, third column you observe. So it's mentioned as 0. So that means, so this is true right now. This is true, but this is not true. This is false. Now it should skip. Now skipped. Okay, see, W has become 4 now. That means it has not come inside. Now I am checking visited of 4 is equal to 0. Is the node 4 visited? No. What we have visited is 1 and 2 right now. And I am checking whether there exists a path from 2 to 4. So V value is still 2 and W value is 4. Whether there exists a path from 2 to 4. Okay. Let me go back to the matrix and check whether there exists a path from 2 to 4. Oh, sorry. So now we will see whether there exists a path from 2 to 4. See, second row, fourth column. Is there a path?
Yes, sir.
Yes. Now this is also true and this is also true. Now if I press F7, it should get into the if statement. Okay. See, it is into the if statement, and what it is saying now, the next node to visit is 4 after 2. Okay, so we print 4. So let me press Alt F5. See, 1, 2, 4. First we visited 1 and then we visited 2 and now visited 4. Now again I am making a call to DFS by passing 4, because 1 we visited, 2 visited, now the most recent node that is visited is 4. Now from 4 I have to find out which is the next node to visit. So I am calling DFS again by passing 4. So W is 4, what we are passing is 4 right now. Now press F7, again I am pressing. So you can just see now V value has become 4 right now. Okay. So because W we passed and the V value is 4. Now visited of 4, we are making it as 1. So visited of 4, we are making it as 1. I will show you. See, this is visited of 1, visited of 2, and this is visited of 3. We have not yet visited the node 3, and now we have visited the node 4. And this 0 don't consider, because this visited array is starting from the 0. So this, but our focus is from 1, this is the index 1, this is the index 2, 3, 4 and 5 till here, and all these things also we don't consider. Clear, right?
Yes, sir.
Okay. Now again w is equal to 1, w less than or equal to n w plus plus. We are starting from the first one. See, w is 1. I am checking whether the first node is visited. Yes, it is visited. So condition is false. Now we skip. I press F7. See, I have pressed F7. Now that means the control has not come here. Now we are in the second iteration of the for loop. How do you know that? See, w value is 2. Now I am checking whether the second node is also visited. Yes, 1 was visited and 2 is also visited. True it is. Sorry, false it is. Again it will not go into this. It skips. I am pressing F7. See, I pressed F7. See, you can see the w value has become 3. Okay. Now again I am checking visited of 3 is equal to 0. Okay. Yes, 3 is not visited. So visited of 3 value is, you can observe my mouse movement. So visited of 3 is 0. This is true. And you got to check whether there exists a path from vertex 4 to vertex 3. So vertex 4 to 3. So what we have to do now, we have to go to the matrix and check whether there is a path from vertex 4 to 3. So fourth row, first row, second row, third row, fourth row, third column. Observe, there is a path. Yes or no? Fourth row, third column is what? 1 it is. Following?
Yes, sir.
Okay. This is also true now. So the node 3 is not yet visited, and there is also a path existing from 4 to 3. Okay, 4 to 3. Now both the conditions are true. The next node that we are going to visit is 3. See, Alt F5. So 3 got printed. So 1 we visited, 2 we visited, and then 3 visited, and then we visited 4 we visited, and then we visited 3. So now you are calling again DFS of 3. So calling DFS because of 3, because you got to find out which is the next node that you can visit after 3. Okay. So w value is 3. Now v value becomes 3 now. Okay. So now you are making visited of 3 is equal to 1. So this is going to become 1 now. So after 4 you are visiting 3. So 3 is visited. So 1, 2, 4 you visited, and then you are visiting 3. Okay. Now w is equal to 1. So w less than or equal to nw plus plus. You are checking whether the first node is visited. Node 1 is visited. Visited of 1 is equal to 0. So false it is. That means this is already visited. So it skips. Now you are checking whether 2 is visited. Visited of 2 is equal to 0. Visited of 2 is equal to 0. V value is w value is 2. Okay. Now again visited of 1 is 1. It's already visited. Again it will skip this. Okay. So skip. Now you are checking whether the third node is also visited. Yes, it is visited. And you are checking whether the fourth node is visited. It is also visited. Now the fifth node, visited of 5 is equal to 0. Yes, 5 is not yet visited. And you got to check what is the most recent node that we visited right now. So it was 3. Okay. So v value is 3. I am trying to check whether there exists a path from 3 to 4. 3 to 5. So 3 to 5. So let me go back to the matrix. So from 3 to 5. So third row, fifth column. So third row, fifth column. That is 1. What does it mean? There exists a path from 3 to 5. There is a path from 3 to 5. Now both the conditions are true. So the node 5 is still not visited, and there is also a path from 3 to 5. Hope it is clear.
Yes, sir.
Okay. So now you visit 5. So Alt F5 I press, you can see. So 5 is visited. Next again you're calling DFS of 5. Okay, so the node to visit after 5. Okay, so I'll press F7, we go back to DFS. Now V value is how much? 5. Okay, so now I go for marking this node, the 5th node, as visited. So it is visited. Now for W is equal to 1, so W less than or equal to 5. Okay, what is this? W value is 5. 5 is less than or equal to 5. The condition is true. Again we get into this, and here we are checking whether I visited the first node. So first node is visited already, so now it should skip. What about second node, W? 2 is also visited. What about 3 is also visited. What about 4 is also visited. What about 5 is also visited. Okay, so since after 5 W gets incremented by one more, and it becomes what? 6. And then what's happening? It is coming out of the for loop and it is printing the new line. And how many new lines it will print? See, how many times this DFS was called? It was called 5 times, and this new line also gets printed 5 times. You can just observe. Return 0 finally. Now if I press Alt F5, see, cursor is here. After this the cursor is here. Why? So how many blank lines are between this output and the cursor? There are 5 blank lines. Why? Because DFS will return. It was called how many times? So initially it was called from the main program, correct? And again inside the function DFS it was called how many times? 5 times. Okay, 5 plus 1 6. Okay, 6 blank lines are here. Hope you understood. So this is the tracing. Okay, and any doubts? Understood now this program? And you're able to solve any graph is given, you're able to traverse it using DFS and BFS, right? Okay, so think we'll stop here, and tomorrow from Monday we will start the sorting and searching techniques. Okay, and after that you have sorting, and after sorting and searching techniques you have hashing concept, hash table concept. These are the 2 things. Okay, 2 topics which are there remaining in the 5th module. I think the non-recursive technique, okay, almost everything is covered. Okay, sorting and searching techniques will start from Monday. So now you people can check your attendance status also. Okay, I'll just show you. So if you log into the data portal, so students login, you have to log in. I have one student password with me. I'll try to log in as that student. So it is updated. Attendance status also you can check, and soon you can also download your fee receipts from here. If you have already paid the fee, so you can download the receipts for the fee payment what you have made. So view attendance is enabled, and soon you'll also get the forgot password recovery, and so if you are registered your email ID, so you can recover your password, and even you can go for setting your own password also. Okay, even that will also be updated soon. Okay, view. So all of you know how to view your IA marks. So now you can go for viewing the attendance status as well. So just click on view attendance status. So you got to select the academic year. Okay, so the current academic year and the subject. Okay, so I have marked the attendance, so it's not there from the beginning. So once you click submit, you have to wait for nearly 5 to 8 seconds, or 10 seconds maximum. Okay, you'll get it. So this is what USN, name, and attendance status for the subject this. So number of classes 26, attended is also 26 and 100%. Okay, and you can also like the dates, and because the attendance was marked from this date, so from 14th October, 14th October, from here till here. So now today's also, if I mark, you'll get the today's also. And if any of the faculty has not marked the attendance in the portal, okay, say for example analog and digital electronics, if I submit, so it says attendance not updated, please contact your subject teacher. So that means this particular teacher has not updated the attendance in the portal. Okay, you can see the attendance status for those subject. The attendance is updated in the data portal. So attendance not updated, please contact your subject teacher. So discrete mathematics, yeah, so she has updated. I think discrete mathematics subject teacher has updated, and not fully. So so she has updated attendance for few days in the month of November. Okay, so and again you can directly log out, or you can move back to the home screen and log out. Now fee receipt is not, I am still developing it. Okay, once it is complete, it will be added. You can also download the fee receipt from here. I'll inform you people once it is done and updated here. Okay, so let me finish taking the attendance. So, and this is the total number of logger, 18,000 till today, 18,927. It was more, so few logs I deleted. So during the second test time I deleted few logs, and these are the number of users which are live on the portal. So 26 users are on live.